Hey Jude.
Our next and final intro topic. It's our most complicated one yet. So far, we have talked about things that most languages share in one form or another, but today we're taking our first big step into the broader world of programming. Some languages are procedural languages like C. Meanwhile, other languages like Java are what we call object-oriented. And no, I don't mean like how capitalism is object-oriented. Now, some of the things I will touch on will be applicable to both types of languages like overloading, but all of them are absolutely essential to understanding how OO works. In this video, I'm going to focus on what an object is and how the identity of an object works. Object orientation is all about trying to turn things in the real world into things our computer can understand. And like the name implies, they're called objects. They are an extension of what we discussed in our last video. When we write a class and fill it with methods and things it can do, we can also fill it with values that describe it. For example, a Pokemon. It has a name, a type, a level, etc. These are all variables, and they can be stored at the class level. For now, we'll make them public to keep things simple, but we'll learn some best practices later that tell us that class variables should almost never be public. A Pokemon can also do things like attack, level up, evolve, etc. These are our methods from the last video. But instead of being static, they aren't, so we can just ignore that word. Static effectively means you don't need an object to use it. But how do we make an object? Well, there are things called constructors that, unsurprisingly, construct them. Java is nice. If you don't give it a constructor, it gives you a default one, which kind of looks like public Pokemon, open close parentheses, open close curly brackets, and nothing else inside of it. But, just like methods, we can pass parameters in to fill up those class level variables. But first, let's give our class's default constructor some default values. So, let's do this.level equals 16, this.name equals wartortle, and this.type equals water. But how about for our custom one with parameters? For that, we'll have a new constructor called public Pokemon string name, string type, int level. Now I made these parameters share the same name as the class variables above, and what you're going to do is assign the parameters to the class variables with the same name. By using the same name, you know exactly what is what. But since they share the same name, you need to tell your computer which is which. Otherwise, the computer goes to the one that is most contained or local, i.e. a method variable. So we'll type this.name equals name, this.level equals level, and this.type equals type. The this means this object, which tells the computer you want to use a class variable. And the other one, without the this, means whichever is closest, i.e. the method variable. And a best practice is to almost always use this when referring to a class variable, just so that the person reading it knows which is which. Which is why in our empty constructor above, we did this.level equals 16, even though there wasn't another level to confuse it with. The one exception is constants because, they're constant. There's nothing to confuse it with. There should only be one of them. Now that we have our constructors, let's make a quick method called sayName that will simply have a system.out.println I'm plus this name. Now let's go back to hello.do and our main method. The first thing we want to do is use our constructors to create two Pokemon objects. First, we'll do Pokemon wartortle equals new Pokemon. Then, Pokemon Squirtle equals new Pokemon Squirtle water 5. Now we can call the objects in their method instead of the class in the method. And watch how they do slightly different things. Wartortle.sayName, Squirtle.sayName. This is the power of Grayskull! Objects. They're able to slightly change behavior based on differences in values instead of being fixed implementations. You can even reassign these values. Wartortle.name equals Blastoise, and then wartortle.sayName. See, it says Blastoise now. And you can even retrieve the values directly too. just like how we used constants in the last video. System.out.println wartortle.name. See? Blastoise. But wait, they get even more powerful, because not only can you change values in an object, you can also change the entire implementation. And that brings us to our next topic, polymorphism. Literally, it means occurring in many forms, and there are two main ways to achieve polymorphism: overloading, which we hinted at in our last video, and overriding, which relies on something called inheritance. So, like we discussed last time, overloading allows us to use the same method name, but have multiple different implementations. So we can have say name that uses our Pokemon's given name, but we can also do say name string name, which allows us to insert a custom name. As long as the list of parameters are different, you can reuse the name as much as you want. Kinda like how Vanilla Ice slightly changed under pressure and won in the ensuing lawsuit. Now the other one is overriding. This means we use the same name, the same parameters, but use a different implementation. This is impossible to do naturally in procedural programming because there is no class hierarchy. Overriding relies entirely on a concept called inheritance, which is best explained via our Pokedex. So all Wartortles are Pokemon, but not all Pokemon are Wartortles, right? So we'll create a Wartortle class that will eventually inherit from our Pokemon class. That's because Wartortle is more specific than a Pokemon, but shares common traits of all Pokemon. So we create our new class Wartortle, and then once it's loaded, we extend Pokemon. And now we have our first class hierarchy. That's the gist of inheritance at the simplest level. Now we get into why inheritance is important from a practical standpoint, the overriding topic. Let's say all Pokemon can say, I'm Pokemon, but depending on what kind of Pokemon it is, changes how it says its name. Pokemon say, I'm Pokemon, but a Wartortle would just say Wartortle, because Pokemon speak by using their name as words. But both of them use that same say name method because it is inherent to being a Pokemon. You could have each one implement their own say Pokemon name, say Wartortle name, etc. And then because of inheritance, each class can use its name or any of the variations of its parent, grandparent, etc. But those names are uncomfortable and impractical to remember all of them, so let's just keep it as say name to keep it simple and sensible. Now it will automatically choose the one that is closest to it. So wartortle.sayname will always say Wartortle. Pokemon.sayname will always say I'm Pokemon. And while Java doesn't require you to do anything else, there is another best practice that we're going to want to start doing. It's called an annotation, which are an entire topic on their own I'll cover later. For now, they start with the @ symbol, then the name of the annotation class. In our case, we'll do @override. This is mostly for us when reading the code 6 months from now to know that the parent class also implements this method. And the computer runs a quick check to make sure that the parent or grandparent, etc. also has this method to override. It's a nice to have that just makes life easier. I want to finish this OO video by discussing an interesting little side bit on objects. Their relationships with mirrors, aka they have reflections. So you know by looking at the code that a Wartortle is a Pokemon. The computer also knows this, and we can use it to our advantage. Imagine if you know that you're getting a Pokemon, but you don't know which kind. It could be a Squirtle or a Charmander. But you really don't care. You just want any Pokemon and for it to do something. So you take Pokemon as the parameter. Then when you call Pokemon.sayname, what do you think it'll say? It depends what you pass in. If you passed in a Squirtle, it'd say Squirtle. A Charmander would say Charmander. This is a super useful strategy when you don't care about implementation and really only care about what the visible methods or interfaces. You can treat them all the same way and it'll just work, even if you don't know how it got there. Reflection can also be used to re-specify something. So say Wartortle has some special method or variable that no other Pokemon has. Java has an instance of Shiny that lets you check, is this Pokemon a Wartortle? So let's try if Pokemon instance of Wartortle open close squiggly brackets, and now we'll cast it or retype Pokemon to Wartortle. So we'll do Wartortle equals open close parentheses, wartortle inside, Pokemon. And now we can use it exactly like a wartortle and get the unique value from it. So let's do say name and see that it prints wartortle. While doing instance of is rare, casting is a powerful tool when you know what something is going to be ahead of time, but have to use a more generic parameter for other reasons, like overriding. And being able to pass in something as a generic object but get the implementation you care about is amazing for code reuse. I think that's enough information for one video. Honestly, even for the basics I could probably make another 2 or 3 videos, but I'm going to try to keep it to the most important things for the intro series, and then do others as part of my future videos. So I'm going to do one more video on the basics of objects, and then start to go and fill in the gaps that I kind of glazed over before, and talk about more in-depth subjects like recursion and input-output. So for now,
I'll be the same, babe.
like, subscribe, and comment below what you want to see next or topics you'd like to know more about.